So, although my house has a whole house surge suppressor wired into its service entrance panel, I'm shopping around for single outlet surge suppressors to protect things like my refrigerator, my garage door opener, my microwave, in other words, my washing machine. Single appliances that, if they got fried, would be a real pita. So anyway, I thought I'd start low and see what's out there, and I started with this 2-pack of really inexpensive surge suppressors. You get 2 in the box. They look like this, and at first glance, and in fact, they're quite well built. In other words, these things are sturdy. I like the plastic. It's shiny. It looks good. The prongs are quite secure. They're not going anywhere, as we'll see when we tear it apart. It's only held together by 4 normal Phillips screws, which is kind of nice if you're going to tear things down. So I did remove the screws on one of the units, which is the one we'll take a look at. So overall, from the outside, it's not too bad. Before I open it, you can't read it, but here's the molded-in nameplate. Made by a company called Lightsun. And it does say conforms to say UL 1449, although it's not UL listed. It is ETL listed, at least, which another YouTuber calls the mark of the devil. The real concerning thing here is twofold, one of which I'll mention here, and that is that it actually lists its pass-through voltage at 900 volts. This means that the surge, or the voltage across the input here, has to start exceeding 900 volts before this thing will even start to suppress the surge. And that, in my opinion, is way too high. As we'll see in subsequent videos, most quality surge suppressors have their pass-through voltage much lower, something on the order of 350, 300, 400 volts, something like that for a decent one. So anyway, without further ado, let's open it up and see what we get. And it opens up with actually no violence required, which is kind of nice, and it all just comes apart. And I guess, again, the plastic is quite sturdy. It doesn't flex. It's pretty thick. I guess the idea is if the thing is going to burst into flames internally, and you'll see it might, at least it'll be more or less contained within this shell. Here's the guts of the unit. It's all on one printed circuit board, which is nice, I guess, and the circuit board's held on by 2 screws, which I also removed in advance. And then it just comes apart like this. Notice the ground pin simply goes through the PC board. The ground pin does not actually connect to anything on the PC board. And in fact, the ground pin, for easy disassembly, can come straight out. So receptacle, plug, and that's it. And again, here's the other plastic shell. Quite sturdy. I like it. It's shiny. It's sturdy. I like this. I like the construction of this thing. Electrically, you'll see it leaves a bit to be desired. So we'll put the ground pin away because it serves, although it will ground your appliance properly, it passes that through, of course, but it serves no other purpose in terms of surge suppression. So here's the PC board. Again, the prongs are nicely soldered and affixed to the PC board in such a way that they absolutely really cannot pull through. So no matter how much you tug on them from the outside, these things are not coming out, and that's as it should be, because they're in fact bigger than the holes on the PC board that they go through. So that's really how it should be. Then nothing on the foil side. Everything's on the component side. And then we have 9, count 'em, MOVs held tightly together by this sort of rubber bandy, heat shrinky type rubber thing, which I've already cut so we can take it off. And that serves to hold all the MOVs snugly together and, importantly, against the thermal fuse, which is this component in the middle. So immediately, the first thing I'm asking is, why 9 MOVs? And when you go into the schematic, you'll see how they're wired. They're all in parallel, and it's not clear what's trying to be accomplished here. This is not at all how, consumer surge suppressors are designed. In particular, the thermal fuse is sandwiched between, well, the two middle ones, if you want, of the stack. So the thermal fuse, if it's working correctly, should notice that either this guy or this MOV are overheating because they've started conducting significantly to the point where they're no longer effective. They conduct and they get hot and eventually burst into flames or whatever. And so then this fuse opens and disconnects it all, as you'll see later. But what happens if this guy starts conducting first, or this guy? Is this thermal fuse even going to see that these outer guys are getting hot? So this whole design makes no sense to me. But if it makes sense to you, let me know why in the comments. Apart from that, we have our token across the line EMI filter capacitor, supposed to reduce line noise. At least it's an X2 rated capacitor. And then the little blue LED down here, which has a diode and a dropping resistor, and is downstream of the thermal fuse. So if the thermal fuse opens, the little blue LED will go out and tell you that you're no longer protected. Of course, your load will still be connected to the line, but you'll no longer be protected if the thermal fuse cuts out. But that's all she wrote. There's not much else going on here. So let's go to the schematic, and it'll be more obvious what's going on. In homage to bigclivedotcom, reverse engineering complete. So the first thing, of course, is the fuse here. This is a thermal fuse. I could not find its rating listed on it, so it's of questionable quality. But typically these things in proper surge suppressors are something on the order of 100 degrees Celsius or 110 degrees Celsius, something like that. In other words, hot enough that it shouldn't get, and if that rating is exceeded, these fuses simply fuse open, and that would simply disconnect absolutely everything south of this. Of course, it does not disconnect your load here, nor is it intended to. So this is not intended to disconnect your load, as most surge suppressors are not. This simply disconnects everything, all the componentry inside the surge suppressor, mostly to keep it from catching fire when these MOVs, of which, yes, there are 9, start heating up or getting excessively hot after they start conducting on a surge or an overvoltage. Again, physically speaking, this fuse is in between right here, but I drew it separately in the schematic for clarity. Again, the MOVs are not labeled. They're blue. That's about all I can tell you about them. We don't know what their voltage rating is. All we know is from the listing molded on the back of the unit, the overall pass-through voltage here of this whole assembly is 900 volts, which is way too high. So that's problem number 1. Problem number 2 is this only provides line to neutral protection. So if your surge comes in between line and neutral, which is actually probably the most common case, this offers some kind of protection. But this does not offer any line to ground or neutral to ground protection, which the latter would be less common, because keep in mind, on your breaker panel, neutral and ground are typically tied together at the first disconnect in the electrical panel. But anyway, most surge suppressors of quality will give you not just line to neutral, an MOV for line to neutral, there'll be another MOV for neutral to ground and line to ground. So sort of a triangle of 3 MOVs rather than 8 in parallel just on line to neutral, which I don't understand at all. If you understand why they're doing this, except perhaps to somewhere else in another universe claim ridiculous joule ratings, let me know in the comments. So again, the second problem is, yeah, there's only line to neutral protection. And then, of course, the problem is there's only one thermal fuse, and it's in between these two MOVs, so it will catch a thermal overload of these two. But what happens if this one or this one all the way out here, because these are all stacked together, starts burning up? Is the fuse going to catch that? Yeah, I don't know. Again, this is all due to the fact that they have 9 MOVs stacked together and only one fuse. I don't know why they have 9 MOVs. Apart from that, here's our noise suppression capacitor. At least it's a line rated, across the line rated X2, 0.1 UF, 275 volts. Let me know if you think this is adequate. Keep in mind this thing is rated to start suppressing at 900 volts, no less. So anyway, that's your sort of token noise suppression capacitor. And then the pilot light. So we have a diode, which is nice enough, 360K resistor, dropping resistor, and then a little blue LED that tells us that we're protecting. The idea, of course, is in the event that this starts overloading and catches enough overloads that these things start failing, the fuse will open and the LED will go out, and you know that you're no longer protected. Although, of course, your line, neutral, and ground will continue. So, I'm not terribly impressed with this, and I really don't understand the design with 9 MOVs. But if you understand it, let me know in the comments. Needless to say, I'm going to be looking further for better choices than this. But it was an interesting teardown. Since there was no violence at all involved in opening this thing up, the design is actually clean enough that it makes it rather easy to put back together. Of course, I did cut this rubber bandy thing, but we can certainly put that back just for appearance's sake. And then we'll see just how easily and cleanly this goes back together. So first of all, let's go find our ground. There's our ground pin. I gotta have that. So the ground pin simply slips in like such. All right. And then this whole assembly slides, very cleanly slides in like such, the reverse of opening it up. And then if I really cared, I would put these 2 screws back in to hold the PC board back in place. And then it's as simple as putting the rear cover back on, sliding all the pins through their little holes, if I can do this. Come on, there we go. There we go. And it slides snugly together. Put back the 4 Phillips screws, and your unit is pretty much as good as new. So I'm actually impressed by the physical design of this thing, because it's easy to tear apart, very easy to put back together. There's no loose wiring inside. Everything's on one PC board. It's actually solidly built. If only electrically it made any sense. And here's the little blue LED that pops out here. One thing you notice it's missing is there's no other LEDs. Most of the things of this ilk have at least one other LED to let you know that the thing is powered in the first place. So there's usually a power LED and then a protected LED, which is what this blue thing is. And then sometimes there's an LED which tells you that the ground pin, that the receptacle that you've plugged this into is properly wired. At the very least, has line to ground potential, so it lights up if you have a properly grounded receptacle. This, of course, has none of that because, well, the ground pin really has no function inside of this unit, although it's just passed right through. Anyway, this was cheap for a reason. So